My name is Karan, Dodia. I'm part of the team with Continuum Analytics. I've been with them for about 9 months now, so I'm still relatively fresh to the scene. But I've got a short presentation, rapid exploration and visualization of large data sets. I'm going to keep this short and sweet. So I'm just going to hit 3 topics: current state of the Python visualization ecosystem. I'm going to give a few thoughts on how to build up visualization, and then we're going to look at the NYC taxicab data set. So these are 3 people that I believe all of you should be intimately familiar with. And if you're not, then you will be after this talk. The first person is Dr. Tukey, John Tukey. He literally wrote the book on exploratory data analysis back in 1977. At that point in time, there was a lot of emphasis on statistical analysis as verification. So you would apply a model to a data set in order to see how well the model fit the data set. But there wasn't really an idea of just load up the data set and take a look at it. That kind of introduction to a data set without a model already in mind with your approach. So it's not a super interesting read, but he laid the groundwork for a lot of later work. The fact that these new technologies are emerging, which enable and whatnot, is we really have to thank Dr. Tukey at least for giving us the groundwork. Second person is Dr. Leland Wilkinson. He wrote The Grammar of Graphics. How many of you are familiar with ggplot? Just by show of hands. Okay, good. So you understand that such a grammar of graphics. It basically separates your description of the data from the way that you visualize it. Instead of having named graphics like a scatter plot, you just have x and y coordinates. You have novel graphical techniques where you can combine, reshape, mash up different graphical forms in order to create novel graphics. Third person is then Dr. Hadley Wickham. He is the author of ggplot2. And I would recommend his thesis, which is called Practical Tools for Exploring Models. Yeah, it's about 130 pages, but it actually goes through start to finish how you would explore a data set. Of course, all the code is in R, so you can go for that. So nowadays, we have matplotlib, plot, and bokeh. Those are more or less the 3 mainstays for statistical visualization in the Python ecosystem. Matplotlib just hit version 1.4 a few weeks ago, and they've really overhauled some of the basics for style sheets. So now you won't have the ugly jet color map as the default. You have a few more options. In fact, they've got one style which is called ggplot, to try and emulate some of the ggplot styles. However, I would highly recommend using Seaborn if you ever get the chance. Seaborn has a couple of, sorry, not even a couple. Seaborn has an impressive array of statistical functions which take your data generally as a data frame. You can provide column names for a regression plot or a hex bin. I'll show a few of those later in the talk. And it definitely needs to be part of your workflow if you're planning to do high-scale statistical visualization. ggplot is actually being actively ported over by the guys over at YHAT. So if you are coming from the R world and you still feel more familiar with that, they actually use more or less the exact same syntax. And then they make that clear. But it does provide a nice familiar interface. Which is the project that I've been working on. In fact, in talk tomorrow by Brian Van de Ven, who is right now the current lead authors. It's 07 release coming up within the next couple of weeks. So you should definitely come take a look at that. So from the grammar of graphics, now in the 21st century, 2014 now, we are starting to evolve a poetry of graphics. You've probably seen more and more, hopefully, scientific talks or lectures incorporate the IPython notebook, and more of the papers that are using Matplotlib and Seaborn to create their statistical graphics will be, creating novel plots. These aren't just the tried and true scatter plots, box plots. These are actually mashing up new and unique graphics. So that's applying both to the data, the way that you demonstrate the data, and as well as the models. I mean, now that we're talking about machine learning, it's really ramped up in the past 5 years, especially in Python. with scikit-learn. We had that entire tutorial this morning. You can see how these models then have to be represented in a visual manner as well. And the problem is there's no good way. There's no right way yet. What we're quickly understanding is that the proper way to show the data really depends on the data itself, really depends on the models itself. We also have novel interactions because we are entering the age of the browser. IPython Notebook makes this explicitly clear because now a lot of analysis is done in a notebook, right? You can start at the top, you can keep executing cells until you decide to change something. So some things that come naturally with D3 style interactions are panning, zooming, clicking, hovering. These are things which are very valuable if you can figure out how to hook it into your code or hook it into your data. But they're not, there aren't very many good Python libraries out there that do that yet. That's actually a really hard problem to solve. They had the MPL D3 wrapper, which Jake Van der Plas wrote, to try and convert matplotlib figures into D3 graphics, right? So you can click, hover, and whatnot, interact. But link brushing, I think, is actually one of the most interesting techniques coming up. Because link brushing can connect across plots. All right, how many people here are familiar with link brushing? Okay, just a few. Yeah, you'll definitely want to see that in tomorrow's bokeh talk. So this is the data visualization catalog. This is the first page. There are 2 more. I'm throwing this up here just so you can see the entire ecosystem of plots that you can create to try and represent your data, right? You've got arc diagrams. You've got different categories that link to one another. You've got your regular histogram, flow maps, especially important for geographical movement or modeling. One of my favorite is the chloropleth map. I'm sure you guys use that a lot. It's also known as the heat map. This is a harder one to plug into because it requires a geographical basis, but there are some Python libraries that are, now bokeh is also trying to hit that same problem. Pie charts, population pyramids, Sankey diagrams, Venn diagrams. I mean, basically every statistical analysis that you can possibly think of, there should be a visualization to accompany it. Because that visualization makes that statistical view of the data clear. And I know it's a somewhat strange statement to make. For exploratory data analysis, you're literally trying to look at your data. You're trying to reshape it or pipe it into a graphical outline which gives you a better intuition for what your data looks like, right? How many of you have fired up an IPython notebook and decided you're going to start scikit-learn machine learning algorithm and you already know which one to use and which parameters? That never happens, right? You have to take a look at your data first. So that's the whole point of exploratory data analysis. So I've got a short notebook here, which is going to be using the New York City taxicab dataset as its basis. If you're not familiar with that, the New York City released in, I think, March of this year to a FOIL all of the taxi trips that were taken in New York City last year. There were approximately in uncompressed CSVs. So clearly, I'm not going to be able to explore all of that on my machine. There are some sampling techniques to try and help you downsample. You can do a random Gaussian selection of your data in order to get a smaller subset to work with. I believe Tony Tran is giving a presentation on that tomorrow, if you want to see more about that. But for this purpose, I've just selected one of the months, February, and I've done a few different plots to try and demonstrate how you can interpret data in a visualization. So I'm loading up here, as well as matplotlib with some Seaborn defaults. And for the first pass, I'm just importing the first 10,000 rows, which is large enough at least to get an understanding of the visualization, but small enough to be manageable on my laptop. So this is our data frame. We've got the medallion and hack license, which are unique to each taxi, vendor IDs, rate codes, which I wasn't familiar with coming from Austin, but they're 1 through 5 depending on the starting and ending destinations. up and drop off date times, passenger counts, trip time in seconds and distance, and you get pick up longitude, latitude, drop off longitude, latitude. So Edward Tufte, in his, I think, one of his more infamous remarks, said that 70 to 80% of graphical representations are scatter plots. And that may be high or low, depending on your understanding, but it's pretty true. Generally, you want to look at the interrelationship between two variables. And so x and y axes provide a great intuitive way for most of us to visualize that. So this is, on the x-axis, we've got the trip time in seconds, and on the y-axis, the trip distance. So literally, this is the first thing I did. I decided to choose two columns, take a look at them, visualize it with a scatter plot. And the first thing you understand is there are a lot of outliers. You can't see them very much on this low contrast screen, but there are definitely some trips that went on for, 35, 40 miles and took 7,000 to 8,000 seconds. We can iterate quickly, bring that down to minutes. So you can see some trips actually took over an hour or over like 80 minutes. If you're doing a machine learning algorithm on this data set, you're not going to want to include some of these outliers as very highly important. So you always have two choices. You can either exclude them from the data set entirely, which generally isn't a good thing to do. But for exploratory data analysis, you're not even there yet. You might want to just zoom in or select a certain area. Here, though, we have the cardinal sin of big data, which is overplotting. How many of you guys ever hit overplotting when you're trying to hit a large data set? You've definitely found that in some corner, generally, where your x and y are minimal, you have too many points that can be adequately plotted. So we have alpha constraints. And alpha is you have to understand, this is an HTML element. You only have ranges from 0 to 255. So an alpha of 0.2 here, which I've specified, basically says that if you have 5 in the same area, you've already hit overplotting again. So in order to avoid this, you have to go into a different regime, which is called abstract rendering. There's going to be an entire talk on that called abstract rendering. Sorry, there's going to be an entire section on that in the bokeh talk tomorrow. But zooming and panning, I know they seem like really simple things, but coming into this data set, if you zoom in on this corner, what do you start to see automatically? Right, exactly. We've got discretization of trip time in minutes. And this is something that may not be immediately apparent to you if you're just scanning through your data, but when you visualize it, it pops out. It's immediate, and it's visceral. So if you wanted to get a slightly better representation of this, you might want to jitter your data points, which creates a small offset either in the x or y direction to try and keep them from hitting the same areas. So what I'm doing here now is in just pandas selection, creating the trip time in seconds, getting all the trips that last less than 60 minutes, just setting a bound. Same with trip distance. I'm looking for trips that are less than 4 miles. And now this is a seaborne joint plot. It uses a hex binning technique in order to generate the hex plot. And this is advantageous over scatter plots or regular heat maps that are on a rectangular grid, because hex plots have 6 angles, right? So you've got a better chance of capturing a point in a particular hex bin than you would in a rectangular grid. This provides also a histogram view on the top and right bar, where you can clearly see some of this discretization effects in the empty columns. So passenger counts. Yeah, you can't exactly do a scatter plot of passengers. This is plotting the trip distance against the passenger count, because I wanted to see how far are most people going if they're in a car versus if they've got a couple friends in tow. But you have a violin plot, for example, which has it's a combination of a box plot and a kernel density estimation. So this doesn't make sense for this kind of data. You don't use a violin plot if you've got discrete units, right? So you would throw it into Seaborn and create a histogram. You can see that most trips are taken with just one passenger, and then it tails off for 2 to 6 passengers. Trip time in seconds. This is where a violin plot would actually be useful. You want to see approximately the distribution of trip length. Are people taking shorter trips? Are they taking longer trips? Are most trips within a certain range? And because this violin plot also overlays a box plot, you can see that the average trip length is approximately 600 seconds. And then you also get the interquartile ranges and a proper kernel of the entire range. But this makes more sense. It actually makes more sense to put time as a linear scale on the x-axis. How many times have you seen a scatter plot where time is on the y-axis, for example, right? You don't generally see evolution of a model as it goes up or down. You see it as it goes left or right. And we naturally, as humans, we think about figures as left and right for time going backward or forward. There's always a better orientation, generally. And that's something that emerges once you start to consider the grammar of graphics. You start to understand that we shouldn't be just shoving our data into statistical plots. We should be trying to look at our data in the broadest fashion imaginable first, and then iteratively choose or select properties of the plot which interest us or which will then yield more information. And part of that is also the figure aesthetic, choosing whether you're going left to right for time or up or down. Okay, so this is a plot of, So what I'm doing here actually is loading the entire data set. So initially I subsetted to the first 10,000 rows. Now I'm loading the entire thing, setting the index to the pickup date time, so then I can sort by the index day, and then plot it as a bar chart. So this is basically going to show me the number of trips taken per day through February by the taxis. And actually, I think this is going to take another 10 seconds or so. So these are problems you have. These are hashtag big data problems along the lines of first world problems. There are a lot of ways to try and interact with data out of core that are perhaps not as intuitive for Python libraries. So if you're at all interested in out-of-core problems, you have data sets that don't fit in memory, or you don't even have 2 columns that could fit in memory, then definitely check out the Blaze talk tomorrow, which is going to be delivered by Matthew Rocklin. Highly recommended. So what's the first pattern you can detect from this kind of data? You see that for the most part, it is relatively normalized. You have approximately 500,000 trips per day by these taxis. And you can also see what are weekly patterns. This is something that emerges when you bring other understanding to the table, that on weekends, you have peak trip times. You have bar plots that extend higher than others. But when you're doing the exploratory data analysis and you don't have that model in mind, it's actually incredibly freeing. Because at that point, you are literally playing with the data. Your conception of the data set is what you bring from external information. Like in this case, I know these are taxi trips. I know they have these pick up and drop off longitudes, and that most taxi trips don't go 40 miles. Most taxi trips don't have a tip that ranges in the 900% range. We're clearly not going to see models that use those outliers as statistically significant points. And on the other hand, when you have the models and you're trying to confirm it against the data, at that point, it's almost like you're taking a test. You've basically decided, yes, this is the approach and the information that we have, and this is how we're going to try and fit the data into our understanding. So here are tips for normal people for the entire data set, right? Again, it's more or less what you've seen before. The subsample actually does a pretty good job because taxi trips are randomly distributed, right? You don't expect that on the 1st of February versus the 15th of February, there's going to be a much appreciable difference. Okay. Yeah, so one frustrating thing about this is that data sets are messy, right? And we hear this all the time. We have data sets are messy. And in order to clean it up, that is also part of the exploratory analysis. If you're doing one thing right, it should be cleaning your data set and visualizing it as you go. Because if you're cleaning and visualizing, you literally see what you're managing to take out of the way. Coming back up here, if you if you decided to clean this data set for appropriate statistical analysis, you're not doing any modeling, you just want to show somebody, right? You're not going to show them this plot. This plot isn't as meaningful as this one. This plot is more meaningful because it's given, well, it's not actually. Okay. That and then that. Oh, and this is, oh, that's going to break my laptop. Okay. Sorry. Okay. So one limitation of bokeh right now is the fact that you can't plot 10 billion points. That's okay. We're getting there. Our goal is still higher, but one thing I was interested in is why so many people tipped 0. This did not accord with my intuition because at the very least, if you're in a taxi and you've got a 15% tip option, if you swipe your card, you could hit that, right? Why is it that most people go for no tip? And so hypothesis A, your taxi driver was an asshole, and you really wanted to avoid giving him any indication that he did a good job, or that there's some other hidden variable at play. And that's what a lot of data analysis actually is determining what that quote-unquote hidden variable is, right? It's not actually present if you're looking at the data set on as an overview, but exploratory data analysis, you'll find some interesting stuff. And type. So grouping into show up and if you're cleaning your data set. So you see a hash, but if you select on fair tip amount to 0 and you do the same group by, do the same plot, you get an error. You get 2 errors. Okay. Yeah, okay, see that's the thing. Sorry, explain it.
The tip amount needs to be a bracket, that tip amount.
Oh.
And the other.
Oh, yeah, that's right. Okay. L strip, guys. L strip, do the L strip. Okay.
The other one needs to be payment amount. We changed it.
Okay, we're gonna.
There you go. There you go. Fix it.
Thank you. So here you go. This gives you your explanation. You clearly see that for some reason cards are completely underreported for tips compared to cash. In fact, it's to the point where you have some statistically significant, at least, you want to investigate a little bit further and see why it is specifically that those cards are giving tips. You can analyze those on other vectors. You can see trip time, trip distance, were they going farther or shorter? Was it some reason that, maybe they were in a hurry and they really need to get out and didn't give time for a tip? Oh, yeah, yeah. Oh, okay.
Which makes more sense that like
Yes.
there's a lot of ways that
Right. Because cards don't report, right. Cards, any tip percentage that's entered, they also have the same amount docked for the credit card processing fees and IRS, right? You can't just collect it the same as cash. Okay. So that's the explanation here. We all know what's going on, or at least you all know for sure what's going on. So that's exploratory data analysis. Some fantastic plotting libraries, okay? It's fantastic. Interesting stuff with link brushing and panning and stuff. To yourself, if you're cleaning a data set, you're using pandas, visualize as you go. Take a look at your data, see what accords with your intuition and what doesn't, and do make judgment calls. Thank you.